beautiful people, and welcome. In today's video, we are talking about graphing exponential functions. Now, we've done this before in a previous video. In this video, what's going to be different is we're going to be using formulas for our reference points. Now, these formulas are based off of the transformations that happen from our parent function to what we have. So part one of this video is going to be graphing using these reference points formulas. And then also in this video, I'm going to show you examples of how to use these reference points formulas to write an equation for our exponential function. All right, let's go ahead and get started. As always, disclaimer time. I am human. If I make a mistake, that's okay. Let me know where the mistake occurs so that way I may learn from it. For our transformation function, basically, when we were originally learning transformations, and I told you that we're going to be using this the entire semester, I honestly wasn't lying. So everything we've learned about transformations before also apply in exponential functions. For example, our A value is going to be our vertical stretch or a compression. Our B value, we learned in the previous video, that's going to be our either increasing or decreasing function. Our H is our horizontal shift to the right or to the left. Remember, H is always opposite of what you see. And for our K value, it's going to be a shift up or down. So for our first reference points, we're going to have H comma A plus K. And so what you do with those formulas is you basically take the numbers from the given equation, plug them in, and plot the point. There's really not much to it. So I kind of prefer this method. If you have a cheat sheet that you're writing, I definitely encourage you to write these formulas down so that way you have it. It's a lot easier and a lot less time consuming than just plugging and chugging all of your values as you saw in the previous example. Now your asymptote is the line that shall not be touched or crossed, and that's going to be y equals k. When they are asking you for let me back up. When they're asking you for an equation for an asymptote. So when they ask what is the asymptote, you can't just give me the k value because that's not the asymptote. The k value is part of the equation for the asymptote. An asymptote is a line, so you have to give me y equals blank or y equals the k value. All right, let's go ahead and jump into an equation and an example. And I have these, again, I don't expect anyone to have these memorized. Have this on a cheat sheet in front of you, and that's what I'm having right now. So the first thing we're going to identify are our values. I'm going to write the formula right underneath here. I have A, B, X minus H plus K. And what you're going to do is, I personally like to start with K. K is just the easiest, but I'm going to write the reference points here. H comma A plus K. Second one is, let's back up a little bit. One thing I didn't mention, increasing, decreasing. So there are two types of formulas for you for your second reference points. If it is decreasing, you're going to be subtracting 1 and dividing A and B. For increasing, you're adding 1 and you're multiplying. Just think of it this way. If you are increasing something, you are making it larger. So you're going to add a 1 to your H and you're going to multiply A and B together, then add in K. Now, if you're decreasing, you're making something smaller. So H minus 1, and when you divide A and B, you're actually making that number smaller. So keep that in mind when you're doing your decreasing and increasing for your second reference points. So how do you know which one's increasing and decreasing? Well, you can do it two ways. Well, actually one way, since we don't have a graph, that's what we're trying to do. You're looking at your B value. If your B value is greater than 1, you have an increasing function. If your B value is less than 1, you have a decreasing function. So since we know our B value now is greater than 1, obviously 2 is bigger than 1, we have an increasing function. So that means for my formula here, for my secondary point, I have 1 plus H comma A times B plus K. And for my third point, I have, well, it's not really a point, it's a line, y equals k for my asymptote line. And we're going to plug and chug here. What do we have? We have H. What is H? Again, always think opposite. So if you see a plus 2, that's going to be the opposite. So I have a minus 2 here. I have an A. We kind of don't have an A. I mean, technically we do have an A. In this case, A is 1. So make sure you don't put 0 here. If there's nothing for your A value that's being multiplied by the B, then make sure that you put a 1. K is a, what is K? K is a -1. That's going to be our first point. Our second point is 1 plus H. H was -2, comma. Then we have A, which is 1, B, which is 2, and K, which is -1. Again, am I getting all of these numbers? I'm getting these numbers from here. Let's see if I can highlight these in different colors so you guys can see a little bit better. So your 1 was your A value. Your B was your 2 value. Your H was your opposite of your +2. Again, just make sure you know that these are opposite. And your K value is the -1. So that's where I'm getting all of those values. And then lastly, we have our asymptote line, which is y equals k, which in this case, y equals -1. Now, you can't really plot this yet because, I mean, there's a lot happening. So let's simplify. For our first point, I have a -2, comma, 1 plus a -1, that is 0. For my secondary point, I have 1 plus a -2, which means I have a -1. 2 times 1 is 2, minus 1 is 1. And we have our asymptote line. So when we are graphing, always start with your asymptote line to graph. So we have y equals -1. Where is -1? -1 is here. And again, asymptotes are dashed lines, not solid. They are dashed because they are technically invisible. Technically, they are invisible. After that, what are we doing? We are just plotting our points. I have a -2, 0. And I have a -1, 1. -1, 1. Now, keep in mind, we know this is going to be an increasing function. So increasing function, we don't have any reflections. You know, our a is not negative, so we don't have any reflections. So it's simply going to be going up a slope, going up a hill. So honestly, after that, you don't really need to do much. You can, if you want, to find the y-intercept. What I recommend is when you're graphing, actually don't label the y-intercepts like this, like label 1 and label 0, because you know exactly where those are at. However, we don't know where the y-intercept is unless you find it. So how do you find the y-intercept? To find the y-intercept, you're going to set the x equal to 0 and solve. So for that one, let's go ahead and set the x equal to 0. And we're going to solve. So y is equal to 2 squared minus 1. So that means y is equal to 4 minus 1. That means y is equal to 3. So that means my y-intercept is 0, 3. X is 0, y is 3. So here's 0, here's 3. So here's my third point. And now we're going to just connect. And this one's going to go up, up, up all the way. This is going to go all around here. And we're getting super duper close to our asymptote line, but we're not actually crossing or touching it. Make sure when you're drawing it, you're drawing a little gap between your asymptote and your curve. Also, arrows are super duper important. All right, so here's one example. Let's go ahead and do one more example for a decreasing function. So here's a decreasing function, and as always, there needs to be an equal sign. But let's write out the formula underneath. So I have a times b to the x minus h plus k. Now, since we know this is going to be a decreasing function, how do I know it's a decreasing? Because this b value is less than 1. So that means it's going to be decreasing. And that's going to be here. Now, this could look differently. It could look different if we have a, any sort of transformation or a reflection across the x-axis. If this a is negative, then we have a reflection across the x-axis, and we need to flip that. Alrighty, let's go ahead and again write out our formulas. Make sure that you are aware decreasing means we're going to be subtracting for our secondary point. First point, h comma a plus k. Second point, decreasing. So h minus 1 comma decreasing. You're taking a divided by b plus k. And your third value is going to be your asymptote line. Just like in the previous example, we are identifying what your A, B, K, H are, and we're going to plug it in as a point. So H right here is always opposite of what you see. So if you see a -1 here, your H value is a +1. Your A value is 3, your K value is 2. And we're doing the same thing. Now we're doing 1 minus 1. Your H value is a +1. We're going to subtract 1. Your A value is 3. Your B value is 1/4. And we're going to add a K value to that, which is 2. And your asymptote is Y equals your K value, which is 2. At this point, you can choose to find your y-intercept. I'm going to choose to do that after. Let me find a different color so I can separate what I've done and what I'm doing. So for our first point, I have 1, 5. For our secondary point, this one you may need to use a calculator if you want. 3 divided by 1/4, you need to multiply by the reciprocal. This is a fraction. So we have 3 times 4, which is 12, plus 2. 12 plus 2 is 14. And I'm already chuckling on the inside because I'm noticing that I only go up to 8. So we may have to improvise there. And let's do our y-intercept. Y-intercept, again, you're setting that equal to 0. You're setting your x equal to 0. You can set all of this equal to y if you want. You can say y equals 3 to the 1/4 power, 0 minus 1 plus 2. So I have 3 times 1/4 to the -1 power plus 1. Make sure you are aware of what it means to have a negative exponent. Negative exponent means make it a fraction, flip it, and remove the negative. Now, since we already have a fraction, we don't need to create a fraction, so I'm just going to take the reciprocal and remove the negative. So now I have 3 times 4. 3 times 4 is 12 plus 2. I hope you guys are laughing. I truly hope you guys are laughing. Check this out. I did all of that work to find the y-intercept when I already have it. So the y-intercept is x is 0, y is 14, and I already had the y-intercept, so I kind of did that for no apparent reason. You just kind of gotta love that math. All right, let's go ahead and sketch this out. So I have 1, 5 for my first point. Then I have 0, 14. This is where I'm going to have to improvise just a little bit. That's okay, because all we have to do is just extend our line here. This is 8, this is 9, 10, 11, 12, 13, 14. It's going to be here, and it's going to be 0, 14. And our asymptote line is at +2. Make sure you have it as a dotted line. There it is. Oops, and make sure you have arrows. I drew the arrow the opposite way. And what you're going to do is connect those 2 points. You know it's going to be a decreasing function going super duper close to your asymptote line by never touching. Make sure you have arrows on both, and that's pretty much it. Hopefully this is an easier way for you to graph. If you prefer the other way, that's fine. Just make sure you have, your reference points for graphing. There's going to be points that I'm going to be looking for. All right, beautiful people, this is part 1. Part 2 of this video is going to be using these reference points to writing an equation for the exponential function. Thank you. Bye.